Alrighty, I'm going to help you review for our polygon test, which is next class. So take out the worksheet that says area and polygons on it, because the review is the back. Problems 9 through 22. Excuse me. Alright, for number 9, it wants us to find the measure of one interior angle of a regular dodecagon. A dodecagon is an 11-sided figure. The formula for one interior angle is (180) times n minus 2 divided by n. N stands for the number of sides that the figure has. So since it's a dodecagon, I just mentioned, it has 11 sides. So it would be 180 times 11 minus 2 divided by 11. So now we grab our calculator. We can type 180 times 9, because 11 minus 2 is 9, divided by 11. And you get roughly 147.3 degrees. Number 10 says, how many sides does a polygon have if the sum of the measures of the interior angles is 6,300? The formula for the sum of interior angles is 180 times n minus 2. Since we're provided with the sum, we're going to replace the left side of the equation with 6,300. And we have to work backwards to solve for n, which is the number of sides, which is what it's asking for. So in order to get n by itself, the first thing I would do is divide both sides by 180 to cancel it out on the right. So 6,300 divided by 180 is 35. So on the left, I'll have 35. On the right, all I have left is n minus 2. And now the next thing I have to do to get n by itself is to add 2 to both sides. So 37 is equal to n. So it says 37, the figure has 37 sides. Number 11 says, how many sides does a regular polygon have if one exterior angle has a measure of 4.5 degrees? The formula for one exterior is 360 divided by n. Knowing that, and they provided us with the actual measurement, we're going to replace the left side with 4.5, and it's equal to 360 over n. I would put 4.5 over 1 and cross multiply. When you cross multiply, You get 4.5 n is equal to 360. And then we divide both sides by 4.5 to get n by itself. So now we grab our calculator and actually calculate 360 divided by 4.5. So you get 80. N is equal to 80. So this figure would have 80 sides. Wow, that's a lot. Number 12 wants you to find the sum of the measures of the exterior angles of a heptagon. A heptagon is a seven-sided figure, but it's asking for the sum of the exterior. It doesn't matter how many sides a figure has, the sum of the exterior is always the same. The sum of the exterior is always 360 degrees. Number 13 wants us to find the sum of the measures of the interior angles of a decagon. A decagon is a 10-sided figure. So the formula for the sum of the interior is 180 times n minus 2. With that being said, since it's a decagon, again, it has 10 sides. So we're going to replace n with 10. And now grab our calculator and multiply 180 with 8. 180 times 8, because 10 minus 2 is 8. And you get 1440. So the sum will be 1,440 degrees. Number 14 says, how many sides does a regular polygon have if one interior angle measures 165? Anytime they give you one interior angle, in this case it's 165, always find its exterior pair. To find its exterior pair, you take 180 minus the interior, which is 165, to find its exterior. And you would end up with 15 degrees is the exterior angle. And now that you know the exterior angle, use the exterior angle formula to help find how many sides. It's a much simpler formula to use than the interior angle formula. So the one exterior angle formula says that it's 360 divided by n. We know what the exterior angle is. We know it's 15. So we can put 15 over 1 and it's equal to 360 over n. And we can cross multiply. In the process, you would get 15n is equal to 360. And then divide both sides by 15 to get n by itself. So 360 divided by 15 is 24. So this figure has 24 sides. Number Number 15 wants us to find the measure of one exterior angle. So again, the exterior angle formula is 360 divided by n. It tells us it's a pentagon, so that tells us it's 5-sided. So we're going to replace n with 5. So it's 360 divided by 5. And grab our calculator. And we get 72. So each exterior angle would be 72 degrees. All right. Number 16 wants us to find the circumference and the area of the circle below. Write our answers in terms of pi and round it to the nearest 10. So to find the circumference, we know that the circumference is equal to 2 times pi times the radius. Currently in the picture, we're shown the diameter, not the radius. The radius is only halfway. So the radius is 12. So to find the circumference, we're going to take 2 times pi times 12. And when they say leave the answers in terms of pi, all we're going to do is multiply 2 with 12 and get 24 pi. That's the circumference in terms of pi. For the area, the formula is pi times radius squared. So that would be pi times 12 squared. And again, they want us to leave the area in terms of pi. So we square 12 and we get 144 pi is the exact area. Now we would grab the calculator and approximate to the nearest 10 because that's also what they want us to do. So for the circumference, we're going to type 24 pi. And then for the area, it's 144 pi. So to the nearest tenth, the circumference is approximately 75.4. And the units are inches. For the area, it's approximately 452.4 inches squared. Number 17 wants us to find the area of a nonagon, or I'm sorry, it tells us the area of a nonagon is 742.5. It also tells us the perimeter is 99. It wants to know what is the length of the apothem. So it's a regular polygon, so the area formula is apothem times perimeter divided by 2. So again, they've provided us with the area, so we're going to substitute that on the left side of the equation. It's 742.5. We don't know what the apothem is. We know the perimeter is 99, and then there's a 2 down below. So I'm going to put the area over 1, and cross multiply. When I cross multiply, I would get 99a is equal to 2 times 742 is 1485. So 99a is equal to 1485. And then I gotta divide both sides by 99. To get a by itself. So divide this answer by 99. And we get 15 for our apothem. Our apothem is 15 units, since there are no provided units. Number 8 wants us to find the area of the polygon below. It's a regular polygon. So again, the area formula is apothem times perimeter divided by 2. The apothem is not shown on this picture, so we have to find it first. Remember, the apothem has to be perpendicular to the side. And it cuts the side in half. So if each side is 18, each part on both sides of the apothem would be 9. So I have to use Pythagorean's theorem to find the apothem. So in order to find the apothem, I would use 9 squared plus b squared is equal to 20.8 squared. We know 9 squared is 81. 20.8 squared is, can't see it, 432.64. Ah, 432.64. There's no decimal there. And then I must subtract 81 from this answer. To get b squared by itself. For those who still don't know how to do Pythagorean's theorem, I'm doing it step by step for everybody. And then we have to take the square root of both sides, which is the part a lot of you all tend to miss and forget about. You have to take the square roots of that answer. And you get roughly 18.75 as B, which is your apothem. Now we can fill in the rest of the area formula. So again, the apothem is about 18.75. To find the perimeter, you take the one side, which is 18, and multiply it by the number of sides it has. So it has 1, 2, 3, 4, 5, 6, 7 sides. So times 7, and then divide by 2. Remember some of our shortcut rules to help you out on less calculator keystrokes. The even number I have at the top is 18, so I can cut that in half. and get 9. So now when I come over and grab my calculator, the only thing I'll type in is my apothem, so I'm going to leave it its exact answer, times 9, oh, I already did multiplication, times 9 times 7. And you get an area of 1181 meters squared. On number 19, they talk about a regular hexagon is 18 centimeters. Find the exact area. So this was one of those special cases I talked about where you have to use a special right triangle in order to find the apothem. So there's always a special right triangle within a hexagon, and the height of that right triangle will be the apothem. So that's your apothem. And then it's always across from 60 degrees. So it's a 30, 60, 90 triangle. Across from 30 is one of the parts of the side where the apothem splits it. So if the whole side is 18, the split would be 9. So that's across from 30. And then always to remember, across from 60 is always whatever's across from 30, which is 9, and then square root of 3. So that means our apothem is 9 square root of 3. So if you can keep that in mind, you should not go wrong. It's always like that. This is the pattern. Make sure you maintain the pattern's consistency. So again, our apothem is 9 square root of 3. Now that we know our apothem, we can find our area, because area is equal to apothem times perimeter divided by 2. So our apothem is 9 square root of 3. To find the perimeter, you take the one side, which again is 18, multiply it by the number of sides. It's a hexagon, so the number of sides is always 6. And then over 2. I could use 18 or I could use 6 and cut them in half. I can't use both, so I'm just going to cut 6 in half. It's smaller, and get 3. So now when I grab my calculator, the only numbers I multiply are the 9 times 18 times 3. Those are it. That's it. Which would give you 486. And then bring down your root 3 and label. So centimeters squared. That's how you find an exact area of a hexagon. Number 20 wants us to find the exact area of an equilateral triangle. It's very similar to that of the hexagon. Again, you're going to have a special 30, 60, 90 triangle within every equilateral triangle. And to find the area for a triangle, you need base and height. So the height of the equilateral triangle will always be across from the 60-degree angle. So this is your height, and across from 30 is half of your base, not your whole base. The whole base is 22, so half of that is 11. And again, since it's a 30, 60, 90, I've already mentioned across from 11, across from 30 is 11. So that means across from 60, you're going to take that 11 and slap a square root of 3 on it. So the height is equal to 11 square root 3. Now we can find the area. Area of a triangle formula is base times height divided by 2. Again, the base of the equilateral triangle is 22, not the special right triangle that's built in. It's always stemming from the original triangle. So the base of the original triangle is 22. The height of the original triangle was 11 square roots of 3. All of that is divisible by 2. I can cut 22 in half because it's an even number. When I cut 22 in half, I get 11. And then I just multiply 11 with 11, which is 11 squared, and that happens to be 121, and then bring down the square root of 3 and label inches squared. So you have to remember the 30, 60, 90 pattern for this test. I cannot stress that enough. It just makes your life easier. Now for the last two questions, they ask you to draw a figure. You can draw any figure that meets the description. So 21 wants to draw a regular convex octagon. Octagon is 8-sided. So in order to be a regular octagon, all sides have to be congruent and all angles have to be congruent. So just do your best to draw a stop sign. And then show that all sides are congruent with the little tallies. So there's 1, 2, 3, 4, 5, 6, 7, 8. Show all the sides are congruent, plus show all the angles as being congruent using arcs. So 1, 2, 3, 4, 5, 6, 7, 8. Number 22 wants an irregular concave pentagon. So they want a 5-sided figure where it's irregular. So a star has 5 sides, right? No, I did more than 5 sides. Okay, hold on. Let me redraw that. An arrow, I think I can get that in 5 sides. Let's try it. There's 1, there's 2, 3, 4, 5. Okay, a flag. It has 5 sides, it's concaved, and none of the sides are the same. It's irregular. So this concludes your tutorial for your test review. If you understood everything on this worksheet, even on the other side with the composite figures, you'll do just fine on the test. So good luck.